Now let's talk about model estimations. Okay, normally, if our data is normally distributed, we will go for maximum likelihood estimation for the estimation of the covariance matrix. So based on our data, we will calculate one covariance matrix that we call the observed model. Okay, and then using maximum likelihood, we can estimate a covariance matrix, which we will call the conceptual model. Okay, and then we compare the observed model and the conceptual model. That's what we do actually in a structural equation model, and we look into the feet of the chi-square. Okay, so we compare these two models based on chi-square. Okay, that's what we do. And so normally for the maximum likelihood estimation, we would like to have normal distributed data, but studies have already shown that maximum likelihood is also robust for non-normal data with large sample sizes. Okay, and then another estimation we can use is the maximum likelihood estimator with the scaled error correction against scaled corrections against non-normality, and the estimation provide standard corrected standard errors and a correct chi-square value. Okay, but normally this approach doesn't work with missing data. And then we have the weighted least square estimators. Distribution fee estimator, good for categorical data, but normally require very large sample sizes. And then we have the diagonally weighted least square estimator, which is also for categorical data, which is the default for categorical data in Lavin, and requires smaller sample sizes than WLS. Okay, so there are actually quite a few more estimators in Lavin which we can use, but normally these four are the major ones. And for the partial least square, we will have the PLS algorithm, PLS estimator, and there are two. One is the PLS algorithm, and there is one more which is PLS consistent algorithm. Okay, so normally when we have a reflective constructs in our data, then we use the PLS consistent algorithm. Studies have shown that PLS consistent is better, provides better estimation when we have reflective constructs.